Okay, now that we've talked about factoring quadratic trinomials in the form of ax squared plus bx plus c equals 0, we've talked about when a, the leading coefficient, was 1. Now we're going to talk about when a is not equal to 1. This complicates a lot of things, and it makes it harder because basically what you have to do is you have to guess and check. They're a lot tougher. I kind of say, you know, you have to remember one thing when you're dealing with quadratics and you're factoring. You're going to be foiling to check. But these problems make me say this, oi! Because how you're going to check these is going to be the O and I out of FOIL. Let me explain what kind of situation we're actually dealing with. An example. 3x squared plus 7x plus 2 equals 0. You'll notice that the x squared term is not a 1. You do not have a leading coefficient of a 1 now. You have 3x squared. So it's not near as easy. What you have to basically do is think of the factors of 3 and write them above it. And same thing with the last term. You're still going to start with your two sets of parentheses. You can still figure out the signs using the last term is positive. That means the signs are the same. So the signs are the same as the middle. They're both going to be a plus. A lot of the other rules we talked about with the other quadratic trinomial situation is you got to throw out the door. Because you can look at it. What times what's 2? Add to 7 doesn't make sense. Now also, how do you know it's these difficult type? How do you know it's a guess and check situation? Well, we will look at that first term, the leading coefficient, the 3. Does it go into the other two terms? No. 3 doesn't go into 7 evenly. It doesn't go into 2 evenly. So that means you're going to have the tough situation, this guess and check. Here's how it goes. We're going to start with the factors of 3. And I usually put 3x and then x. If you FOIL that, 3x times x gives you the 3x squared. We got our signs. All we got to do is figure out the back numbers. Which one goes there? Our choices are, we only have 1 and 2 to put in there. Well, the signs are the same, yeah, but now we got a 3x and an x. It does matter where the 1 goes and where the 2 goes. So, well, here's where the part where we're going to guess. I'm going to put the 1 here and the 2 here. And let me explain what I meant by the oi out of FOIL. The oi part is to check. You're going to take the 3x times the 2 and the 1 times the x. That's the O and I out of FOIL. 3x times 2x, 6x. 1 times x, 1x. What does that give you when you combine those? 7x. That's what you want. You want that middle term, so we know we factored it right. Now, we still have to solve for x. We can look at the easy one right here, and we know already that x is equal to -2. Why? Because the x term has got a coefficient of 1, so we can just take the opposite of 2. This guy is a little different. Now, here's what you do. Write 3x plus 1 down, set it equal to 0, and then solve for it. Now, listen carefully, because I'm going to kind of go through what you do, but I'm going to tell you how you can do this mentally in your head really fast so you can speed up the process on your test. We're first going to subtract 1, giving us 3x equals -1. So you did take the opposite of this number. Opposite of 1, positive 1 is a -1. Now we're going to have to divide by 3 to get x by itself, giving us x equals -1/3. Here's how you can do it in your head really quick so you can answer it faster. When you have a number in front of the x, you just take the opposite of the second number. Opposite of 1 is -1. And then you divide by the coefficient of x. So take -1 divided by 3, -1/3. You get it very fast. You need to work on speed. Let's try another one. 5x squared minus 17x plus 6 equals 0. Now, first thing you want to check, does 5 go into all those terms? No, it doesn't. So that means it's a guess and check. It's this special situation. So write the factors of 5. 5 and 1 above the 5, and then the factors of 6. Uh-oh, there's more than one set. You have 1 and 6, 2 and 3. Now, last term's positive again. That last term's positive. That means the signs are the same. Same as the middle. So they're both going to be minus. Now, since the only factors of 5 is 5 and 1, we can go ahead and put 5x and 1x in here. Now we have to choose. We're going to put a 1 and a 6 or a 2 and a 3. Well, I'll tell you what. If this number was really, really, really big, I would maybe use the 1 and the 6, because if I put a 6 here, 5 times 6 is 30. That would have had to been a lot bigger than 17. So I'm going to try the 2 and 3, and a lot of times you're going to use the smaller ones, the numbers that are closer to each other. So let's just, I don't know, let's throw them out there. Let's put a 2 here and a 3 here. Now we got to do oi and a FOIL. So we're going to do 5x times negative 3. That's negative 15x. And then we're going to take the negative 2 times the x, and that's going to give us negative 2x. When you combine that, those two guys, that gives you negative 17x. That tells you we did it right, because we got the middle term. If you would have had the 3 here and the 2 here, you would not have gotten negative 17x. So it's a trial and error. It's a guess and check situation. Now we still need to solve. Now let's see if we can do that, solve for each factor quickly. You have 5x minus 2. You're going to take the opposite of negative 2, positive 2. Write it down. Then you're going to divide by the coefficient of x. That's the 5. That's done. You got the root there. The 0, the solution. This one's x minus 3. We just take the opposite. You can even do it with this one. Opposite of negative 3, positive 3. Divided by 1 still makes it 3. So it works for that situation too. Now let's try one more that's harder. 8x squared minus 14x minus 15 equals 0. Okay, first always check. Does 8 go into all those? It doesn't. That means you got a guess and check situation. Let's go ahead and list the factors of 8. Well, 1 and 8, 2 and 4. So those are the possible front numbers that you're going to put in. 15, you got 1 and 15 and 3 and 5. All right, before we put any numbers or x's in there, let's get our signs. Last number is negative. And we learned earlier when the last term is negative, the signs got to be different. Why? Because it positive times a negative is a negative. They got to be opposite in sign. Now we have to choose 1 and 8 in the front or 2 and 4. I'm more inclined to use the smaller numbers. That usually works out for some reason. This would still have to be a lot bigger number to convince me to use the 1 and 8. So let's put 4x and 2x. Now the back parts. Well, I'm not going to use 1 and 15 because if we put 15 here, 4 times 15, that's way more than 14. Even if we put the 15 here, 2 times 15, that's way more than the 14. So let's use the 3 and the 5. Well, you got to take a guess, so let's just 3 and 5. Now don't forget how we check. Oi! 4x times negative 5. That's negative 20x. Then we got to do 3 times 2x. That's positive 6x. What's that give you? Negative 20x plus 6x, that's negative 14x. And that's what we wanted. Now, some things can happen. Say you had the minus here and the positive here. What would happen in that situation? Well, if you had the signs in the wrong place, you would have had a positive 20x and a negative 6x, giving you positive 14x. So if you ever find yourself in a situation where you got the right number but the wrong sign, catch yourself saying the wrong signs, that means you got the signs in the wrong place. So all you would have to do is switch the signs location and you would get the right number and the right sign. Now we've got to finish this. We've got to find the roots. We've got to find the solution of this quadratic equation. What would be the solution to 4x plus 3? Again, take the opposite of the 3, negative 3. Divide it by the coefficient, 4. You got that one done. The other one, what's the opposite of negative 5? Positive 5. Divide by the coefficient, 2. And you got your two roots, your two solutions to this quadratic equation. Okay, the last type of factoring situation with quadratics I want to talk about is when you're going to factor a difference of two squares. What does a difference of two squares look like? It looks like a squared minus b squared. Difference of two squares. Difference means you're going to have a minus between the terms. Two squares, you're going to have two things that are squared. A difference of two squares. How do you factor a difference of two squares? That's going to factor into something called conjugates. We talked about that in foiling. Conjugates would be the same binomials but opposite in sign. And if you foiled this out, you would get a squared minus b squared. Now let's talk about how you're going to handle with numbers. If you would have put say a 25 in front of this, you would have to put a 5 in front of the a, and same thing with the other one. So you're going to end up working with the perfect squares again, like you did in Pythagorean theorem. So you got to know your perfect squares. Here's where they're going to come into play a role now. So let's take a look at what you would do in this situation. Say I gave you 4x squared minus 9. You'll notice that there's two terms. That's what's different from a quadratic trinomial. 3 terms, 2 terms here. Binomial. You'll notice that you'll see these numbers are those perfect squares we mentioned on that list of them. So what you're going to do is put your signs in there. What's the signs? Oh, hey, we can still use that from the other section. This is the last term. Last term is negative. Signs are opposites. We can go ahead and put plus minus. Now we know that these guys got to look the exact same, but one's a plus and minus. We got that taken care of. So the numbers that go in here and here got to be the same. So you're going to have to square root those numbers. What's the square root of 4? 2. So you're going to put a 2x and a 2x in the fronts of each one. What goes in the backs? What's the square root of 9? 3. And if we set this equal to 0, and we had to solve, let's solve each one. Again, you're going to start with this number. What's the opposite? Negative 3. Divided by the coefficient of x, 2 in this case. You're done with that one. Go to the next one. The opposite of negative 3, positive 3, over the coefficient 2. You'll notice they're the same number, but opposite sign. Most commonly, we write that as x equals positive or negative 3/2. Depends on how they want to write it on the ACT. You'll see it either way. So know that they mean the same. Let's do another one. 16x squared minus 25. Well, you'll notice how many terms we got. We got 2. They're separated by a minus. Hey, those are those perfect squares. That should be a red flag for you. If you want to factor it, what goes in the fronts? Square root of 16, 4x, 4x. Last term's negative, sign's got to be plus minus. What's the square root of 25? 5. If this was set equal to 0 now, we can solve it. The opposite of 5 is negative 5, divided by the coefficient 4, and you're going to get the opposite of 5, positive 5, over 4, and you can write that as positive and negative, plus or minus 5/4. All right, let's kick it up a notch. That adds some tougher numbers to it. One more, and I think we're done with it. 49 x squared minus 64. We'll set that, go ahead and set that equal to 0. Bigger numbers, you got to know those perfect squares. Square root of 49, 7. So 7x, 7x, plus and minus because the last term is negative. Square root of 64, that's 8 and 8. So after a while of doing these a few times, you're going to be able to go right to plus or minus 8 over 7.